2 years back, when Bhaskar Ramurthy and I started working in the area of solar energy, we started working in the area primarily because of the huge problems that we are seeing with respect to power in the country. Power cuts almost every day for hours. Most of us were suffering in the summer particularly. So we started looking at the solar energy. As soon as we started working on the solar energy, we saw several contradictions. Solar photovoltaic on the rooftop was giving us DC power. We were then computing a MPPT point, a DC-DC converter, and then we are converting it to a AC power. Why? Because all of us just use AC power. And then we are taking to the lights, fans, electronics, and then we have to occasionally store it in a battery. We are again converted it to DC, stored it in a battery, and then when we needed to take the power out from the battery, we converted it again from DC to AC. This multiple DC to AC, AC to DC conversions were resulting into huge losses, as high as 40 to 45%, and solar power at that time was very expensive. Did it make sense? We knew that the LED lighting can make a huge difference. Its power consumption can be half to 1/3 of the regular conventional, even CFL light. Compared to tungsten bulb, it will be far lower. The biggest usage in India is that of a fan, and a fan again uses AC induction motor. Typical fan consumes around 72 watts, and we found that if we actually replaced this with the BLDC fans, brushless DC fans, the power consumption will again go down to 40%. And then there was all the electronics, whether there was a television or a laptop, cell phone charger. We knew the electronics uses only DC, and we are using AC to DC conversion. We started measuring the conversion efficiency. The efficiency at best would be around 70%, very often under 50%. We are losing huge amount of power, huge amount of expensive solar power. It is at that time we started deciding to work on DC power along with solar, and we said we will make a difference. It has been 2 years, and today I am very glad to see that this lab, CSTRI, we have actually converted it to a DC powered lab with a product which we have designed called Green Offices and Apartments, GOA. It takes solar power, it takes power from the grid, it has the option of a battery. Everything is then taken on a DC. A DC lighting is used, DC fan is used, and DC powered electronics is used. This is the equipment where one of the input is from solar panel. The solar panel input comes to this equipment. The incoming grid power, AC power, comes to the equipment, converts to DC, and this also has a battery storage. Then the DC power can be stored in the battery and can taken out of the battery when needed. Stored when there is surplus power, taken out when needed. We then take it to a DC line where we can add all this and then either power homes or power offices. We can power 12 homes or 24 homes. This solution has been designed for 12 homes. There are other solutions, similar solutions, just scaling up for 24 homes. Just come with me to show you. This whole lab is DC. You see the number of lights, something like 25 lights. They all look tube lights, just look like ordinary tube lights, very similar to ordinary tube light. There is a lot of difference. These are LED tube lights. You have fans, something like 12 fans, and these fans are all BLDC, brushless DC fan, DC powered fans. We are using 48 volt DC sockets. Here are those sockets. They use a very special kind of connector. We wanted it to distinguish it from the AC connector, and this is a simple cell phone charger, and this is used with connectors, can be plugged in like this, and you can power the cell phone, you can power the laptop, you can power the television. Take this fan. Since we designed this brushless DC fan and we designed it in 2013, we said, well, we might as well design it with the infrared. So we actually can now, for example, shut this fan off simply using this remote. This fan can be turned on and turned off. This fan at the full power consumes 32 watts as opposed to a normal AC fan which consumes 72 watts. What is more important, that when I run this fan at speed 1, then at the lowest speed it consumes only 11 watts. The same remote controls both the lights and fans. I can turn it off, I can turn it on. What is more important, I can dim these tube lights to very low value. Now it actually consumes only 4 watts. I can increase the brightness to about 8 watts, to about 12 watts, to 15 watts, to 18 watts. This is a full-fledged tube lights. We power these tube lights and fans and sockets for electronics all through a DC main box. This DC main box has the circuit breaker. It is also has a meter of how much am I consuming, and in fact I can read the meter on a laptop, on a personal computer, on a mobile phone. I can even get it remotely read, and as I turn off lights the power goes down from 145 watts, suddenly it has gone to 130 watts. What do we have? We have a solution which is extremely cost effective. With volumes, the cost of a DC fan will be no more than an AC fan. Cost of tube lights is going down very, very significantly, higher than CFL, but then the lifetime of these lights are almost 8 to 9 years as opposed to CFL, which is about a year. The plug points will not cost any more than a AC charger, and the efficiencies are extremely high. We have designed the solutions to power 12 homes, 24 homes, 12 apartments in an apartment complex, 24 apartment in an apartment complex, or take rooms like this, take labs like this, offices like this, having 3,000, 5,000 square feet. We can actually convert all of them to DC, solar powered DC, if required with the backup, at a far lower capital cost and per unit cost as compared to anything available today. Thank you very much.